Okay, so good morning everyone. My name is Kevin Davids. I'm a systems engineer with Datacore Software. Today we're running the Overcoming the Performance Hurdle webinar. We're looking how to optimize and virtualize your critical apps using Datacore's SAN Symphony V storage hypervisor. Now, this is a 25-minute webinar. In which time we'll just cover the top surface, if you like. We're not going to go into too much technical detail on this, and that's because we have a mixed audience today of users and partners. It's an introduction to the approach of how we look to overcome the issues. It's not going to be overly technical. Now, for that reason, this is an invitation for those technical administrators, engineers who are on the webinar today. If you want a more deeper dive into the technology, then please contact me or contact your local Datacore representative, and we will arrange for a more technical conversation and product demo. You can test drive the product in one of our labs. You can do proof of concepts. You can download a 30-day evaluation. And likewise for users as well, if you want to play around with the product, then of course evaluations are available to you. What we're looking to do today is to get an understanding of the demands of those tier 1 or critical applications. We're going to look then at how SAN Symphony V optimizes the underlying storage, and we're going to back these up with some real-life stories. Questions I will deal with at the end of the webinar. I'll take a quick look. If we've got a lot of questions, then what I'll do is just end the session and get back to everybody as a group with the answers to those questions, lest we end up on this webinar for over an hour, which I don't think we want to do. So what then are those tier 1 critical applications to which we're referring to? Well, they could be Microsoft SharePoint, SQL Server, Exchange, Oracle, SAP, but they are really any application within an organization that meets the criteria that they have to be the following. They have to be accessible, so always on, highly available. They have to be underpinned with business continuity. These are the applications that if they go down, there is a real critical hit on the business. So we need to make sure they're constantly accessible. These are applications that are quite often scalable as well, or demand scalability from the storage. These are applications that may be underpinned with databases that are constantly growing, and therefore the demands on the storage that's also constantly growing as well. The performance of the application is absolutely key. Therefore, speed is of the essence. And from a storage perspective, that is being able to deliver fast storage back to the application. And flexibility within the underlying storage is absolutely key. We need to be able to have different types of disks. They need to be located in different areas. We're not looking at having a locked down box or monolithic storage array controlling our storage. We need to think a little bit more around the flexibility. So tier 1 applications or critical applications demand more from storage, but the demands of accessibility, scalability, speed and flexibility are exactly the same for the application itself. So this then leads us to two options when we're looking at our storage. If our storage has to be accessible, then we need to make sure that we have high availability and disaster recovery. If we're looking for performance, we need to make sure that the disk, the underlying storage, can give the performance demanded by that tier 1 critical application. And traditionally, the way that we do that would be to add more spindles. In terms of scalability, it's adding more disk. In terms of flexibility, it's adding different disk types and having a management structure in place. But there's two options to achieve this. The first option is to add more hardware. If I need performance, I need to add more spindles, so that adding more disk takes the load for performance. I have to overhaul my storage infrastructure. If I'm looking for high availability and I have a storage vendor with a storage array, and all of my data resides within that array, I need high availability. I need to mirror from that array to another array. So I go back to that particular vendor, I buy a like-for-like disk array and their own proprietary software to enable me to do synchronous mirroring. If I can't do that with vendor A, then I need to rip and replace with new disk from a different vendor. So we then become tied in to the actual underlying disk. So we can throw more hardware at the problem, or we can look at a more flexible, cost-effective, software-based solution, and that's what we're going to be talking about today, where SAN Symphony V can optimize the underlying storage. Now, with tier 1 applications then, one of the problems is that if we have to add more hardware, overhaul the storage infrastructure to be able to get the levels of high availability of performance from an underlying storage area network, then the temptation is not to put our tier 1 application storage in a storage area network, and we revert back to having direct attached storage. Now, the disadvantage here, of course, is that storage isn't highly available, but we're getting the performance from it. So we've seen over the years that people have been reluctant to put tier 1 storage in storage area networks. Of course, with data core as a layer, then we're able to do that. We're able to provide the scalability, flexibility, improved functionality for a storage area network, and be able to protect the demands for tier 1 storage. So our advice is to take a fresh look. Let's look at virtualizing. Let's look at consolidating databases, achieve higher service levels. Let's accelerate app delivery. When we virtualize the servers, we've reduced the number of servers. We've attained better business continuity, and we've reduced costs. We want to be able to bring all of those to the storage. And we need to overcome major obstacles of equipment downtime, of I/O bottlenecks, and facility disasters. And we see virtualization as three-dimensional. We've seen over the years desktop virtualization with VDI. We've seen server virtualization through Microsoft, through Xen, through VMware and others. And what we're looking to do is to bring the same benefits that you get from virtualizing your servers and virtualizing your desktop to the storage. So SAN Symphony V is a storage hypervisor layer that sits between the underlying disk and the applications. Now, those apps could be virtualized or not. With tier 1 critical apps, it may be better to keep them on their own standalone servers. And traditionally, traditionally have their own direct attached disk. But we can use the underlying disk within a storage area network a lot more intelligently with SAN Symphony V. So we have our tier 1 app silos. We have our virtualized tier 1 apps using Microsoft, VMware, Xen, et al. And we have our data core layer Now that data core layer provides caching for performance and also resilience. It has high availability and disaster recovery. So how would that look like? Right. In a traditional data core environment, we would have our application servers and we would have a SAN fabric. Now that fabric can be fiber channel, it can be iSCSI, or it could be a mixture of both. It could be that our normal tier 2 apps don't need the performance of fiber channel. So why not put those over iSCSI and have our critical tier 1 apps who demand high performance over fiber channel? So we have a mixture of both types of fabrics, fiber channel and iSCSI, within a data core environment. And we create a fabric where there is no single point of failure. Now this clearly is a best practice. We don't want our tier 1 apps to lose access to the data, so we would always put in at least 2 data core servers. Now the software sits on standard Windows servers. Now we lock down the operating system to ensure that they become a secure appliance, if you like, but a secure node. You can have these as virtual VMs, or you could have them as physical. If we're delivering up tier 1 apps, then quite often they will be physical servers, and they can be servers of any manufacturer that you want. So the manufacturer that you would normally have, whether it's IBM, HP, Dell, Fujitsu, whoever. And then we have the underlying disk. So we have 2 data core servers, and these data core servers are synchronously mirrored. Now we use the RAM on those servers for the caching. Now SAN Symphony V uses Windows Server 2008 64-bit. That allows us then up to 1 terabyte of RAM in those servers. We use that RAM for the caching. Now in most organizations, 32, 64 gig of RAM is perfectly adequate. However, you have the ability to add as much RAM as you need in terms of performance. So one of the concerns of virtualizing your tier 1 app previously would be, well, by putting in a layer between the disk and the application is going to slow down performance. Well, with us, what it will do is it will actually improve performance. We're using the RAM on the servers for the caching. If you therefore have disk that has caching as well on the arrays, then we're going to be caching to cache. Now we cache the reads and we cache the writes. So when I write I/O from my tier 1 app, it's going to be written to the cache in the first data core server. It's then written to cache in the second data core server. When it is in cache in 2 places, then an acknowledgement is sent back up to the app, and we're able to stage that write down to disk. We therefore have continuous availability, high availability of the underlying disk. So if I lose one data core server, then we just fail over to the other data core server. In terms of the reads, we read blocks up into cache as well. So we will prefetch blocks into cache. If you're looking to read block 1, then we'll prefetch blocks 2, 3, 4, and 5. So we're getting the performance, therefore, from the RAM on the servers as disk caching. So we're actually speeding up as opposed to slowing down, which is one of the risks of taking from direct attach from your tier 1 app onto a storage area network. Now likewise then, that can be any type of disk underneath and any amount of disk. So you can add disk on the fly. We are now introducing flexibility into the equation. Those tier 1 apps that you might have writing to fast SAS disk today may need the demands of solid state disk in the future. Or what we can do is we can just add that disk. But we can also auto-tier as well. So we can create disk pools and populate those pools with different types of disk. So you could have some solid-state disk, you could have some fast SAS disks, some medium-sized speed SAS disk, and even some slow SATA disk within that pool. As we write a block, it's written to the fastest available disk in that pool. We then check the frequency on the reads on that disk. And as the frequency drops, then what we'll do is we'll move that block of data down to slower disk and slower disk still. Then when you look to read that block of data, we'll promote it back up to faster disk. So we auto-tier within a pool, and we can use 15 different disk types that we can tier across. You set a profile on the virtual disk. So the virtual disk that you're serving up to your critical app, you can give it any one of 5 profiles, from critical down to archive. Now, an example would be if I have an application that demands fast storage, but however the blocks of data will be read infrequently over time, I may give that critical app a normal profile. If I give it a normal profile, it'll write to the fastest, but then quickly move it down to the slowest disk within the pool as the frequency of the reads drops. In this way, what I've done now is I've created a pool of physical disks that doesn't have to all be fast solid state disk. We can have a mixture of disk available. We've provided high availability locally for our critical applications, but there's also the need for disaster recovery. And we can have an asynchronous mirror off-site for disaster recovery and off-site replication. We can also migrate data across different disk types. So if you have a disk array currently and you're serving up to your tier 1 critical apps, to your SAP, to your Oracle, and you're looking to decommission that physical disk array, using SAN Symphony V, we can migrate that data off of the old disk onto new disk within a pool, and when that migration is complete, then we can decommission that physical array and remove it without any downtime at all. We can add as much disk as we want, and we can scale out. So we could have up to 4 data core servers sitting within a server group, serving up disk to our servers. We can also scale out the number of sites that we have for disaster recovery. So we could have up to 99 different sites with a central hub or data center and have replication between those sites. And that replication could be bi-directional as well. This is adding even greater disaster recovery ability to our critical apps. If I have an office in, let's say, Berlin and another office in London, then Berlin can replicate to London and London can replicate back to Berlin bi-directionally. So I've talked about how we use the RAM on the data core servers to give performance. Well, what would we expect then in terms of a performance improvement? Well, ESG have done lab validation, so an independent validation of the performance improvements that you get with SAN Symphony V, and they saw a 5 times performance improvement on Exchange. But if we look at the other workloads on SQL Server, Exchange, File Server, and streaming media, we can see that all of them have an improvement by putting the SAN Symphony layer in place and using the caching to improve the performance. So what about some successful outcomes? Well, we have a few, and there's been many a conversation within Datacore when we looked at targeting customers with tier 1 apps as to whether this was new. Well, of course it's not new. Datacore has been around since 1998, and we delivered Sans Symphony in its very first version in 1999. And since then, the vast majority of our customers have been applying Sans Symphony V to provide disk to their tier 1 apps. Bitburger Brewery, one of Germany's largest and best loved brewers of beer, use SAP R3 users, and they need high performance. And Datacore serves at speed better than the legacy systems, and availability has increased significantly. Across down in New Zealand, Ports of Auckland, their tier 1 applications, Exchange, SQL analysis and SQL reporting and SharePoint, see far more virtual machines and far more I/O requests and improvements being made by using Sans Symphony V. Mitt Media, Swedish newspapers, printing and media outlets, their tier 1 applications, Oracle and Exchange, have found better performance using Sans Symphony V than they did using local disk. Amnet, supplier of private cloud managed IT service, saw that Sans Symphony V doubled the performance of their existing EMC disk arrays, Datacore managing them. Their tier 1 applications, quite commonly Exchange, SharePoint and SQL Server. And a quote from MLS, since we started using Datacore on the storage side of Virtualize our tier 1 applications, we got back on track with our virtualization project. Before that, I/O bottlenecks and the pesky outages were hitting us at every turn. They've seen 300% more SQL Server transactions on the same underlying hardware. We must remember at all times that we're not talking about ripping and replacing your underlying disk. By putting Datacore in place, we can still use the same hardware that you already have, and we'll see improvements of availability and performance through Sans Symphony V. So, the result of virtualizing your underlying disk is that you get faster virtualized tier 1 applications. We see continuous availability, so always on, and this is achieved through high availability locally and disaster recovery off-site. Less time and money spent on storage and migrations. We can auto-tier across different disk types within a pool. We can add disks to the pool on the fly. We can remove disk from a pool without there being any downtime, so in a non-disruptive way. And instead of being locked down by a particular vendor and a particular disk array, we now have a much more open environment. You're able to use the disk that is appropriate for you within your environment and that meet the demands of your critical applications. We can see then that we become more responsive, more agile, more flexible, and a much more competitive IT environment. And in achieving all of these things, it's given us peace of mind. So the storage hypervisor, that is Sans Symphony V, applies across the board. This is perfectly scalable no matter the size of the organization. It doesn't matter whether you're an organization of many tens of thousands or hundreds of thousands of users or just a few users. Those critical applications are as critical to your size of business, no matter however big your business is. So we can meet the demands of small businesses, of mid-sized corporations, and of large enterprises in exactly the same way. Doesn't matter the size of the organization, we provide a high level of business continuity in that always on scenario. We add performance to those critical applications. We provide disaster recovery and flexibility of the disk. And for cloud providers too, we are becoming more and more the storage hypervisor of choice, because we provide that level of flexibility that you're looking to achieve. So, in conclusion then, our to-do list: pick up clothes from the dry cleaners and virtualize storage. What I will do now in the remaining minute or so is just take a look to see if we've got any questions and see whether I can answer the questions here and now. Okay. Question from Dominic. Hi, do you have best practice guide regarding data core with Exchange 2010? In support home, I can only see the best practices regarding VMware, etc. Dominic, yes, we do have some documentation regarding Exchange 2010, and what I will do at the end of this webinar, I will send that to you, and I will forward the link to everybody else as well. Eloise, what about disabling write cache if one of the 4 data core servers is offline? Yes, that's a very good point. If I have, and a common environment would be with 2 data core servers, but yes, we can have up to 4 within the pool. We mirror one-to-one. So if I have 4 data core servers, so data core servers A, B, C, and D, and I create a virtual disk on data core server A, it can be mirrored to one other data core server. I can't have 3 other copies. So we would always look at a relationship of one-to-one. So I've got 2 data core servers with my synchronously mirrored virtual disks. If I was to lose one of those data core servers, then obviously I don't want I/O writes sitting in cache on the other data core server. If I've lost one server, then if it's all within the same data center and there's a power outage, I could just easily, within a few seconds, lose the other second data core server. And if I've got writes sitting in cache, then I will have lost those writes. So what we do automatically is that we force cache write-through on the second data core server. So if I lose data core server A, then I'm writing straight to disk on data core server B. So we protect the writes. This way, if there is any critical failure anywhere within the fabric, then there is no loss of transactional I/O. At the host layer, there is also MPIO. Now, this could be embedded within the vendor itself, but with Microsoft, we have our own multipath I/O from the host system as well. So again, anywhere within the fabric, there's no loss of transactional I/O. So yes, we disable the cache writes, and we do that automatically. But of course, the reads are a different matter. The reads are already residing on disk, so we can still read from cache if I've only got one data core server down. So there's no performance impact on that one. Do I have references in the banking sector? Yes, we do. And what I will do is I will send you examples of case studies within the banking sector. We have them all across Europe, and we even have sites which are replicating between different offices in Europe. So we have a bank in in London that replicates to Frankfurt, and Frankfurt replicate back to London as well. So what I'll do is I'll gather together some banking references and I'll send that to you. Dominic, thank you for your reply. Hi, what happens when I allocate more storage to my VMware infrastructure than license? Will it stop until I buy more terabyte licenses? Okay. We license according to the amount of underlying disk that is presented to data core, not that we're presenting up to our applications. So if I have a pool of disk that is 10 terabytes, and I'm only licensed to 10 terabytes, then I cannot add any more disk to that pool until I license it to do so. So if I need to add another 2 terabytes, I simply phone up my data core partner and I buy an additional 2 terabyte license, and I simply apply that license. I can then add the disk. I think the question there is, what about serving the disk up to those applications, in this case VMware? Well, we serve up virtual disks, and because those disks are virtual, then we can serve up any size of virtual disk that we want. We can serve up to 1 petabyte. Now, we're not licensing the virtual disks, so you can serve up as many virtual disks as you want. So let's say I have a license for 10 terabytes. I can serve up virtual disks well in excess of that 10 terabyte limit. Okay, they are virtual disks. What I am licensing is the underlying storage presented to data core and available for data core to put into the pools. So I hope that answers that question. If it doesn't, then let me know. Can we get your presentation? Yes. Yes, this presentation is going to be issued to everybody following the webinar. Okay. One of our customers is asking for a 40-kilometer mirror implementation while he can use iSCSI interconnect line. What are the iSCSI mirror link limitations? iSCSI is 10 gig line. Well, a question of terminology here in mirroring. By that, I'm presuming that you mean a synchronous mirror across 40 kilometers. Now, to answer that question, let me explain how our synchronous mirroring works. When I write I/O, I write it to the cache in the first data core server. It's then written to cache in the second data core server, and in this example, that would be 40 kilometers away. When it hits cache in 2 places, then the acknowledgement is sent back. Now, I would suggest that the infrastructure that you're very briefly describing here would not give us the low latency that we require. Latency would be too great to sustain a synchronous mirror across that using iSCSI. So I would recommend talking to your data core representative and getting a local systems engineer to actually run through in more detail what may be a better infrastructure for you. Yes, synchronous mirror. Okay, Pav, thank you. Right. I think that concludes everything so far. Yes, this webinar will be has been recorded, so you can listen again to my ums and my ahs as I try to explain this, or I may re-record. But the presentation will be issued to you all later on today. So this just leaves me to say thank you very much for your time. I'm repeating the same webinar again next week. So if you did miss out on anything, please don't hesitate to join. And I hope to speak to you all again in the future. Many thanks.